Okay, so this isolator switch on the end here is for directing the solar towards the battery banks. Okay, so battery bank 1 is the 400 amp hour bank that's primarily off the inverter. Battery bank 2 is the 300 amp hour, which are these batteries under the step here, which are primarily the house electrics. I mean, they're both house electrics, but I've split it into inverter and house electrics. So this is directing the solar panels to the different banks, and with it on the bottom you can see that it says 1 and 2, so that's going to both banks. Now the way that the battery monitors work is that if it says plus, that's what's going into the batteries. Okay, so into the 300 at the moment we've got 3 amps going in. At the moment into the 400 we've got 7 amps going in. These banks are fairly full, that's why it's going slow. So in summer, well, most times you can probably leave this on 1 and 2. I tend to leave it on 1 and 2. But in winter, if you were really wanting to monitor your use and be careful, you might want to switch this more to 1, say, because you won't be getting as much solar. But to see how you get on, I mean, I'd leave it at 1 and 2 to start with and see how it gets on. Okay, back to this panel. This is the inverter. So to operate the plugs and everything, you need this on. It's got 2 modes, which is a power saver mode, auto, which means that it uses less power. But with this sort of setup, I would be tempted to just leave it on power saver off. If you put it on power saver auto, you'll find that the fridge, which runs off 240, the light will come on and off as the power saver operates. So you don't want that. Just leave it on power saver off. Okay, so when you're drawing out of the batteries, this will say minus. What I'm going to do now is turn the electric heater on. Now this uses, this is in the boiler of course, this uses about 45 amps at 12 volts. So what you'll find now is when I turn it on, it'll suddenly go to minus. Okay, can you see how it's gone down to minus 20 here? That's actually still putting a bit of power back in. Now what's happening now is that the solar panels are working out how much to give. So like I said, this heater needs about 45 amps. But what's going out of the batteries, because it's a good, although it's a cloudy day, so the sun is up, what's going out of the batteries is, I've just heard the fridge actually kick on, what's going out of the batteries is about 8 amps. So that means that the solar is producing about 40 amps, and we can check that by checking the different series of panels. So I've just pressed the A circuit and it'll tell me now, okay, so I'm getting 15 amps, almost 14.9 in, coming in on the A circuit. Now if I add that to the, let's see what's coming in on the B circuit. So that's 15 amps there. This has got 9 amps, so that's 24 amps added together. And the last circuit, that's 24 amps, is 18 amps. So 24 and 18, that's 42. So with what the inverter uses about 3 amps, this uses about, the water uses about 40, 45, and the fridge uses about 50. So you can see how all these numbers add up. But yeah, I'll leave the water heater on, because with this boiler, well, not with the boiler, but with the plumbing system, they've actually fitted a very useful thing, and that's a thermostatic valve. If you can see that red cap there, it says close and open on it. What happens is if the boiler drops below, I think it says 8 degrees. So if it gets cold, what that valve will do will automatically open, shed the contents of the boiler, and if your pump was on, it would shed all your whole water tanks. The pump wouldn't turn off; it'd keep dissipating. That's why I leave the pump off. But what it does, it protects the boiler from freezing, basically. But since you're living full time in it, I can't see that ever happening, because you'll either have the heating on, you'll either have warm the water up via gas or by solar. So you probably won't come across that. So that's that situation.